In the section 18 warm-up, we're asked to solve three equations for different variables. Question number 1, we're asked to solve for x. Number 2, solve for y. Number 3, solve for x. So what I first noticed was that all these equations have x's and y's in them. So I decided to start going and combining like terms to see what happened. So by adding these guys up here, the 2x's, 2x and the 2x, that ends up giving me 4x. And then I noticed that when I have a 5y and a negative 5y, they end up canceling each other out. So one of my terms eliminated. And on the other side, I've got 12 plus negative 8, which is 4. So solving that, I get x equals 1. For number 2, I solve for y. So in this case, again, I'm going to look to combine like terms. I started with my x's, 3x and negative 3x, and they cancel out. And then I looked at the y's, which were negative 4y. Plus a 1y, which would give me negative 3y. And on the right-hand side, I have 13 plus negative 10, which is 3. And I solve that, and I get negative 1. For number 3, solve for x. So I'm going to get my x's here. X plus 7x is 8x. And negative 6y and positive 6y cancels it out. And I'm left with 32. So then I solve that, and I get x equals 4. Now what all three of these equations have in common is, yes, they have x's and y's, but when I solve them, one of those variables drops out or eliminates. And that's what the section is really all about. It's about solving equations with two variables by using a method called elimination. In activity 1, we're taking some problems here, and we're actually knowing what x and y are, and we're plugging those in to find other variables. So we have our equation here in part A, 2x plus 5y equals 12. If we know that x is 1, we can take that number and plug it in where we see x, substitute it in, and then solve for y to get that y is equal to 2. Then we do the same thing for b. We're going to take x equals 1. We're going to plug that in. We have 2 times 1 minus 5y equals negative 8. Solving for y, we get the same thing. Interesting, because the inputs are the same, and we end up getting the same outputs for those two. Part C, we take our y value, which we know is negative 1, and we plug it in. Plug negative 1 into here, solve for x, we end up getting positive 3. Take negative 1, plug it into question D, solve for x, and we get 3 again. So C and D had the same input, and we end up getting the same output. In question E, x equals 4, we plug 4 in, we solve for y, we get negative 3. And do the same thing for f, plug 4 in for x, solve for y, and we end up getting negative 3. Again, the same input for E and F, and we get the same output for E and F. Now the reality is what we just found was the solution to those equations. We found out the point of intersection between the lines for A and B without actually graphing them. We did the same thing in C and D. Without having to rearrange that equation to solve for y to graph it, we found out exactly where those points are going to those lines are going to intersect. So like in E and F, when x is 4, y is negative 3 for both of those equations. What that means then is our solution would be the ordered pair 4, comma, negative 3. We're going to take a look at that in activity 1b. In this, we're going through the process of elimination. So we're kind of the warm-up and the activity 1A, we're just leading into it and how the process works. But this is where we really get into the heart of it. So to solve the system of equations, basically what I'm going to do is, the first thing I always want to do with systems is make sure that they're kind of by themselves, lined up, so that I can have a little bit of space to work. I don't really want to solve them up here, because I don't think it's really going to work out too well for me. So I brought these equations down, just rewrote them. And if I add these up, this is what I was doing in the warm-up. Let me move up to that real quick. These equations, I was just adding them together. The one part was 2x plus 5y equals 12. And the other equation was 2x minus 5y equals negative 8. And in just a second, we'll go back to that activity 1b, and you'll see those are the same exact equations. The purpose of that warm-up was to get you to the idea of adding those equations together to try and solve it. So let's get back to activity 1b, and you should see those equations again. There they are. 2x plus 5y equals 12, and 2x minus 5y equals negative 8. So when we add these up, we know the y's will cancel, and we're going to have 4x's and 4, and we get x equals 1. That's part of our solution, but it's not the whole thing, because we need to find out, according to the question, the y coordinate. We have the x, we need the y. We're going to take that value of x, which is 1, and plug it into either one of those equations. Oh, wait a minute. We did that in activity 1a. Notice we had 2x plus 5y equals 12, and x was 1. That's what we found. We have 2x minus 5y equals negative 8, and x is 1. No matter which equation we plugged it into, we got the same value of y. We got 2. So our answer then is the point of intersection 1, 2. In question 2, we did the same thing. And again, this will reference warm-up question number 2, because that was the two equations added together to find out what y is. And then also part C and part D of activity 1a, because once we got the value of y, we plug that in to find out what x is. Now, I'm going to caution you real quickly. This is a very common mistake when you're solving a system of equations. If you find y first, that's not your first ordered pair. Y is always the second one. So it's still going to be x comma y. It doesn't matter what order you solve it in. In part 3, we use the same thing. This one references warm-up question number 3. So again, these two added up would end up giving us x is equal to 4. And then part E and F from activity 1a, where when we took 4 and substituted into either equation, it didn't matter, we got negative 3 for the output. Question 4 was completely new. It wasn't referencing anything else, but it was just kind of a tie-in to what we've been doing with elimination. We're going to add these two equations up. We've got an x and a 3x, which is a 4x. The 4 y's cancel, and we have 13 and 7, which would give us 20. Solve for x, you get 5. And now I chose to plug 5 into this equation up here at the top, because we're dealing with positive numbers. I want to avoid negatives wherever I can. So by plugging that 5 into here, I pretty much guaranteed that that was going to happen. Take 5 away and I get 8. Divide by 4, I get 2. X comma y, 5 comma 2. And that's my answer for that system of equations.